Hello, everyone. If you're watching this on the live playback on YouTube, you may want to fast forward a little bit because I'm just going to give some folks a few minutes to come in. I'll put a timestamp down in the description section or the comments. But today we're going to be learning about NodeJS. Hello to people joining. It's 30 degrees tomorrow. Kill me. Just giving a few more minutes, guys. Maybe 1 minute or two. How's everyone doing? Okay, let's just get started now. So, in the continuation of the Let's Learn series, in my previous ones I did Redis, MongoDB, Docker, a whole bunch of things. Hey Clovis, how's it going, man? So I did a whole bunch of Let's Learn series, just learning things from fresh perspective. So in this one, I'm going to be talking about Node.js. I'm not coming from this from like a completely blind perspective in terms of like my experience. I've kind of just jumped into using Node.js without really learning it or like learning about the functionality. So just helping people out, looking at some code, writing some code, but not really learning about it, like spending the time sitting down and saying, okay, I'm going to learn about the fundamentals of Node.js. So that's kind of what I want to get out of this. Being mostly a Java developer, the syntax is obviously going to be familiar, but there's a whole bunch of things that I do in Java that I don't know how to do in Node.js that I want to learn about. So I found this neat little tutorial. It's from something called Rhythm School. It's got a whole bunch of sections. Probably going to get through a couple sections today. But if you want this link, I'll put this in the chat. So if you want to get this and follow along. I'm not going to be writing any code today. We're just going to be going through what's here and then just following along and trying to make sense of what's going on. So that's the agenda. So without further ado, let's just get right into it. And by the way, on the chat, if you have any other questions or anything you want to clarify, or you see I'm flailing with something and you think you can help, feel free to chime in. So we're going to go through this article. I think it's got like a video or something. Yeah, there's a video here at some point, and then a whole bunch of other little things. And yeah, we're going to go from there. So to give you an idea of where I stopped learning JavaScript, this was basically like I used to do a lot of front end stuff back in the day. And this was 5 or 6 years ago when Knockout was a thing, when Angular was just coming out and getting stabilized as the de facto front-end framework of choice. And then kind of as I was heading out the door to become a back-end developer, I started seeing that React started to take the position of the dominant player in terms of front-end frameworks. So that was the kind of age that I was interacting with in terms of JavaScript. But it seems like it's become something totally different now with Node.js. And so my intention here is to learn a little bit about that. So let's see what we got here. So objectives. By the end of this chapter, you should be able to install. Okay, we're not installing anything. Enter the REPL. Okay. Learn how to use CommonJS. Okay. Introduction. We've been writing JavaScript exclusively in the browser, but the browser isn't the only environment. Today we use JavaScript to build applications, mobile server-side applications. It allows us to build these types of applications in Node.js. Okay. Installation. So I heard of this. I don't have NVM. If anyone suggests to use NVM, I don't really see what the use is to be able to switch between different versions. But if there's something that I'm missing here, please feel free to tell me. Maybe I just don't know enough about it right now. Okay, what do we got? So 2 ways to do hello world. Once Node's installed, simply type node, and now we're in the REPL. So console log, okay, that's standard. From your command line, create a file called first.js. Okay, so they're just launching from a file now. This is installation, this video, so I'm not going to watch that. Probably watch the one on the next section of this tutorial. So what is this? Common JS. So Node.js comes with built-in support for modules. These are not the same as 2015 modules. Okay, so that's about where I left off. These are called Common JS modules and require syntax that makes use of the require module and exports keywords. In Common JS, every JavaScript file is a module. Every JavaScript file is a module. So you know what we're going to do is I'm going to grab a notes Sublime thing because I want to take some notes on this stuff as I read. If I can pull it over successfully, which is a challenge. Give me a second here. There it is. It's on my other mod. What the heck? There we go. Lovely. Okay. Let me just make the appropriate sizing changes. Okay, that looks pretty sane to me. Okay, so what are we doing here? We're talking about Node.js, right? Minimize some other things. Okay, what did I just say? Oh, is my face covering the notes? Hold on, let me pull myself to the bottom right here. There we go. Okay, what did I just say now? Every file is a module, right? Every file is a quote-unquote module. Let's make this a little bit bigger. And we use the require module and exports keywords. Every JavaScript file, blah, blah, blah. We need a way of loading JavaScript from one file to another. And modules are our answer, okay. Back when I was doing this, we had just used global, but I guess things have changed. Module exports. So let's take a look at some examples using Node.js modules. File name helper.js, and which will export some data to another file called main.js. So what are they doing here? So supposedly this is a file called helper.js. So we're saying module.exports. I assume module here is a name in the global key space. We're setting a property of name called Ellie and a function that takes no arguments of just say hi. Oh, is this new? This templating thing? This looks new, like backtick. That's cool. I want to write that down. Let me just copy this. What do I want to say? Well, it's a little bit too big to use arrows. Templating, right? Using the backticks, pretty neat. Okay, so now what? So now in main.js, let's add the following. So const helper is equal to require. Okay, so this is he's just pulling in this module over here, and then he's storing it as a helpers file. So this is like similar how you do like an import as if you're in like Java language. And then you're just calling the function. So I assume here if you change this to like foobar, it would be foobar.sayHi. I don't think the name actually matters. I think it's just a coincidence that helpers is the same name as the file name, but I could be wrong. Maybe I'll confirm that later. Okay, if we run node main.js, we should see the text hi Ellie in the console. So how have we done this? We use the module exports object to send an object from one file. Okay. We use the require keyword followed by the name of the module. Notice the node.js is needed because the file is assumed to be JS by default. All right. We are using relative path here. This is very important because if we do not use a relative path, Node will assume you're referencing a built-in module or package. Just notes here, make sure to use the relative path when importing, or Node will think you are using the built-in module. When you're using your own module, always use relative paths, okay? So exports shorthand, what is this? Make a file called more helpers and use the export syntax. So this file is more helpers.js when we're saying, okay, so we're just exporting some functions here. So hold on, I want to go back to what we just had up here and compare. So module.exports, So he's setting, so it looks like these are identical, like exports dot something is equal to something else is synonymous with what we have over here, where it's module dot exports, and then you're using a JSON notation or Java object notation. So, okay. I guess they're the same way of doing something. So let me just put that down. The above is same as this. And I guess it would be say hello, right? And then it would be this. And if anyone wants these notes after, I can share them on the video. I don't know if anyone's interested, but if you are, I'll share them. Okay, so where were we? We can see the above object. Instead of wrapping everything inside the module exports object, we can attach values to the exports object, okay? Which is basically shorthand for module exports. Let's require this module back in our main.js. Okay, now we're getting both now, right? And we're saying helpers.sayHi and then blah, blah, blah. Okay, this is pretty basic. Exporting a function instead of an object. But this doesn't have a name, right? So in this one, he's doing exports.name is equal to the function, but here he's just saying, so this is this like the default function or the constructor function of this, whatever file this will be? Let's see. So here we are overriding module.exports to point to a function instead of an object. So when we require the module, it gets imported as a function. Okay, so then by that notion, then if this is even more helpers, then we should have like, I haven't looked at the answer yet. We should have something that says even more helpers like that, right? So what are they doing down here? So helpers, okay, so they're requiring, they're calling console log, okay. Okay, there we go. So by using this notation, so that's interesting. I think that's noteworthy. So default, what's the word? Default module functions, which allows you to do this basically. Allows you to do this. Okay. That makes sense. So since CommonJS modules are plain objects most of the time, they of course also support object notation, shorthand, and ES6 destructuring. Okay, so module that exports my pets. Oh, so we're exporting this. Wait, I think this does something different. Does it export the contents of, like, well, module? Can you do whatever this module name is .dog now? So my pets. Okay, hold on. So so he's requiring my pets, and then he's exporting it right here. Or sorry, he's declaring my pets, and then he's exporting it here, and then here he's requiring it, and then I can't remember what this notation does. I think it pulls out the attribute on the myPets object. So I guess that is what this is like denoting, that by just putting in the object name here, you're giving access to dog and cat in this example. Hey Leon, how's it going, buddy? You should be able to do .dog. Okay, so using index files. So a nice benefit to using CommonJS files is utilizing index files. In any folder, you may have a file named index.js, which lets you reference its parent folder instead of the actual file itself. Hold on, I need to reread that. A nice benefit to using CommonJS files is utilizing index files. In any folder, you may have a file named index.js, which lets you reference its parent folder instead of the actual file itself. In other words, these two syntaxes are equivalent. Okay, I guess that's just another neat little shorthand. When building larger apps, you can leverage this advantage by having your index.js files require everything in their folder. Oh, okay. So the index can be like your entry point that requires a whole bunch of other things. And then you can kind of, instead of having to define all the imports in each of these individual files here in this example, then you can just import all the dependencies in one index.js file. So that's pretty neat. They're doing destructuring, what it's called. I'm doing great. Good to hear. So I'm gonna write that down. Destructuring. Let me just Google that right now, actually. NodeJS. What's this? I just want like a crisp example. Is this what he's talking about? AB. Oh, okay. So I don't know if this is the example we were like looking at. Is this just like a concept? Hey, Ciatar259, what's up, buddy? Hold on. When in doubt, go to Stack Overflow. Blah, blah, blah. Okay. First answer. Update node. Okay. Jesus. This is not helping. Stack Overflow, you're failing me. Oh, okay. So there's different types. Got it. That's array. Yeah. See, Leon just corrected me. Okay, got it. So this looks like a good example. So destructuring objects. So we're saying first name is Jane, last name is Doe, and then we're saying first F. Oh, so is now F. Got it. Okay, so this is a nice little shorthand. So let me just write this down because this seems like something that people do regularly. And then we can say this, and I want the comment too because that's helpful. And then we could say first is J. Okay, got it. Okay, so this seems like it's let me take all this. It seems like it's helpful. Do people do this a lot in like the real world, development world? Or is this just something, because sometimes there's features that exist that no one really uses, but I'm not sure if this is one of those. That it goes with that. Okay, so what did I say, right? So like, allows for quick shorthand extraction of fields from objects, right? Example below. And what was the array one? It looked like the same thing, but array destructuring works for all iterable values. Intervals A and B, const x, y is equal. Okay, this seems less useful. Let me just take that. My big head is covering it, of course. And like that. Okay, hold on. When can destructuring be used? Can be used in the following locations. Assignments XA doesn't seem helpful. Interesting. Okay, well, I think I need to look into this one a little bit more later. I'm not going to dwell on this too much. Just curious, do you mind giving a 1-minute overview of your background? Are you a backend engineer? Yes, I am. I work at a big company, let's say, and so I've been doing backend engineering for 4 years now. I program primarily in Java. I've done some dabbling in JavaScript. I do a lot of like pet projects with Python, but I do realize that Node.js is getting quite popular and I should probably know it. On my day-to-day, I work in like the realm of distributed systems. I work a lot with AWS and managing like control flows of some I can't get into too much detail, but some mission critical applications that help power some very important backend systems. But yeah, I'm mostly working with like Leon said, like databases, asynchronous orchestration, API design, how to basically set up applications, especially like big applications that are like microservice oriented. I do a lot of how to model things correctly where things make sense so that they're reusable, so that we can extend as opposed to rewrite software. That's kind of what I do now. And as I kind of get more senior in my career, unfortunately, I don't get to write a lot of code lately. So this kind of tickles my itch of learning. It's mostly just meetings these days and kind of telling people what they should and shouldn't do. So that's a little bit about me. But yeah. Kind of went off on a tangent there. Hopefully you found that useful. That kind of gives you a frame of reference for where I'm coming from here. So where was I? So, okay, we kind of went off on a tangent on destructuring. We have models with 3 files in it. Okay. We create an index file that just exports those 3 for convenient imports elsewhere. Require, yeah. Okay, and then we're doing that shorthand destructuring to gather all of those. Okay, cool. That seems useful. A note about ES6 modules. If you're wondering why NodeJS doesn't support ES6, ooh, someone said that in the chat, right? ES6, I think Sadar was talking about ES6. They're working on it. Okay, well, this will make me as a Java developer happy, so I get some familiar syntax. I can read more about it here. Well, this is from 2017. Maybe this is a thing now. Is import a thing now? I don't know. What is this? Express fundamentals. I don't really want to watch that. I think I got a good handle on importing and exporting. Okay, let's go to the next one. So by the end of this chapter, contrast how Node defines built-in modules versus, okay, I may just like skim through this. This doesn't seem that interesting. So far, we call these modules core modules. So this is like standard library kind of thing. Yeah, so like reading off your file system. I do want to stop if they get into thing like promises and blocking. Okay, I think they do that next, so I'm good. So you're requiring file system, you're reading off file text, callback function, writing it back. Make sense? Ooh, videos. So asynchronous. So this is what I'm interested in. This is kind of like tickles my fancy because like I like programming languages and how things are built more than using them really. So what we are seeing is that the entire Node.js environment supports asynchronous behavior. When one process begins running, it does not necessarily block the rest of our code from continuing to execute. That's useful, but can be problematic. In other words, the other code doesn't have to wait for asynchronous functions to complete. While this makes Node.js very effective for certain tasks, it also makes it tricky to manage when first learning it. We'll see how to manage our asynchronous code using callbacks, promises, and async functions. But it's essential to remember that Node.js uses the event loop. This is something I've heard about to handle processes asynchronously. You can read more about this here and here. This is a fantastic video about the event loop. I kind of want to watch this video. How long is it? "26 minutes. It's a lot. Maybe I'll just like skim through this. Okay, Stack Overflow. Nobody's actually asked this. Why is Node.js asynchronous? So does this have a... Sorry, I just want to see like... Usually I like to look at the answers to see what I'm getting into. I want to see what the other one he mentioned. What is this? Okay, pictures. I like it. It seems like it's more for idiots, so I'm a fan. Okay, so this is the third post, synchronous programming. In traditional programming practice, most I/O operations happen synchronously. Okay, yeah. If you think about Java, okay, good. This guy's giving me something I know. About how you would read a file using Java, you would end up with something like this. Yes, exactly. What happens in the background? The main thread will be blocked until the file is read, which means that nothing else can be done in the meantime. To solve this problem and utilize CPU better, you manage threads manually. Well, kind of. You can use a thread executor, but that's a different conversation. If you have more blocking operations, the event queues get even worse. True. The red bars show when the process is waiting for an external resource response and is blocked, and black bars show when your code is running. Okay. Green bars show the rest of the application. So, okay. So you run a code, you fire off some requests, now you're blocked. It comes back, and then you perform the next thing. You're blocked again, blah, 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 blah. This is standard just synchronous programming. Okay. So to resolve this issue, NodeJS introduced an asynchronous programming model. It's a form of input-output processing that permits other processing to continue before. Oh man, this probably becomes such a headache, unless the syntax is very clear, of things like not being defined yet, or like I hope they have a way to say like I want this function to be synchronous and blocking. I would assume that's the case, but let's see. Some delicious water. In the following example, I will show you a simple file reading process in Node, both in synchronous and asynchronous way, with the intention to show you what can be achieved by avoiding blocking your applications. Let's start with a simple example, reading a file using Node.js in a synchronous way. File, okay, so you're importing, you're declaring, you're trying, you're logging, and then you're logging again. Okay, so this was synchronous. So what happened here, we tried to read a file, blah, blah, blah. It works as expected. The content variable will contain the content of file MD. Right. So in this sense, like if this were asynchronous, you know, you'd fire off this and you possibly do this before this gets assigned. So if it's asynchronous, the possibility of this being null is real. Depends on the timing. But anyways, the content variable will contain the content of file.md. Right, makes sense. The problem with this approach is that Node.js will be blocked until the operation is finished, meaning it can do absolutely nothing while the file is being read. Let's see how we can fix it. Similar to, Leon says, similar to task going to other tasks, creating kind of like a DAG. So DAG stands for Directed Acyclic Graph. So yeah, I guess that makes sense. It's kind of just mapping out where to go next, right? So I used to work a lot with, I remember using promises a lot. And at the time, promises were just getting big. We just really, like when I left Node.js, or not Node.js, when I left JavaScript, promises were becoming very popular. For a long time, people were just using like ridiculous, deeply nested callback functions that just called other things. And it was just spaghetti to maintain. Oh, and jQuery was a huge thing at the time. I don't think anyone really uses that now. Yeah, I should do an audio call with Leon. Leon, what's your background? I'm curious. You seem to be very knowledgeable. So let's see how we can fix this. So asynchronous programming, as we know in JavaScript, can only be achieved with functions being first-class citizens of the language. True. They can be passed around like any other variables to other functions. Functions that can take other functions as arguments are called higher-order functions. One of the easiest examples for higher-order functions. Yeah, you can pass them around, right? Okay, this is normal. Oh wait, hold on. What is this doing? Oh, so filter takes a function as input, and that function must take one argument. I don't think there's anything like really saying it must take one argument, but it can. It can take at least one, and then it applies this function to it. Okay, that makes sense. Leon is a college student, just trying to dabble in too many things. Yeah, it's good to get a good wide breadth of skills. I'd say it's also, I guess it depends what year you're in. If you're in your senior years, I think it starts to make more sense to hone down where you want to go. And to give you an idea of what I did like web development stuff first. Like I did a computer science degree, obviously, and then I did web development stuff for a little bit. And then I found like this is kind of interesting, but backend seems more fun. And I don't know if you guys know, but in the industry, there's a very negative connotation, or at least there was. There's a very negative connotation to front-end developers because front-end developers are kind of looked down upon by back-end developers. And it's unfortunate, but it's kind of true that if you're a front-end developer, you kind of get treated as a second-class citizen. Although I know it's complicated, like this isn't basic stuff anymore. It used to be like, just jQuery and all that, but now it's like all these different libraries, all these nuances. It's like, good front-end guys I really respect. So just like kind of keep that in mind too. But anyways, I was saying like, I think it's important to hone in on what you want to do in terms of career path. There's a ton of jobs for full stack and front end. So if you're coming from this just as like, you don't have a computer science degree, it probably makes more sense to start with a front end role. Just because it's easier to get into, and then you can kind of like leap forward into back end later if you get into a company and stay there for a while. But like if you have a computer science degree, you can just basically start doing whatever you want. But if you don't, then it probably makes sense to start with front end. But again, it really depends on your interests. But yeah, anyways, sometimes I just kind of go and start talking. In the example above, we pass in a function to the filter function. This way we can define the filtering logic. This is how callbacks were born. That is true. If you pass a function to another function as a parameter, you can call it within the function when you're finished with your job. No need to return values, only calling another function with the values. These so-called error-first callbacks are in the heart of Node.js itself. The core modules are using it as well as most of the modules found on NPM. Okay. Wait a second. So this was the synchronous way of doing it, right? Oh, okay. So this is just callback functions. They're just, yeah, sorry. It didn't completely click for me there. So yeah, just providing a callback function to do whatever you want. So this would be asynchronous. So, okay, that makes sense. So whenever the read file is complete, you would run this function as opposed to, blocking your thread. Okay. Things to notice, error handling. Instead of a try catch block, you have to check for errors in the callback. Right. Right, okay. I see. So I guess the contract is that you get, like whenever this function is called, the contract with the read file API is that you get a payload of this function that has error in it and content. And then you can kind of read out. This is similar to how like jQuery Ajax calls were done at the time. Okay, that makes sense. Things to notice. So no error handling, true. No return value. Async functions don't return values, but values will be passed to the callbacks. They don't. So values don't return values, but values will be passed to the callbacks. So this is being returned to this function. But then where does it go? I guess if you like assign a variable to the output of this, then it would get whatever is returned in here. Like if you return an actual function or an actual value. I don't know. Maybe that's something I'm going to try. This is an interesting experiment. Okay, let's keep on going. Let's modify the file a little bit to see how it works in practice. So requiring, and then he's doing the callback, detecting for errors. Return console.log. Does that make any sense? This is a void function, right? How are you returning? Unless you just want to return right here. Okay, and then you're console logging the content. The output of the script will be, you start, okay, let's trace this. So start reading of the file. Right, okay, so because this is a callback, so this is the timing thing, right? So because it's asynchronous and it's non-blocking, this kind of just gets like rapidly passed over. So it'll trigger this process in here asynchronously, but it'll immediately drop down to the next line before this block of code can be executed. So what you end up seeing is kind of like what we had here. You start reading the file, This gets passed over very quickly, and then we jump down to end of file, and then end of file. And then anything here can happen later. So, I mean, depending on the speed in which this stuff runs, or the read file function runs, it's possible that, like, you know, this can return before this, but, you know, in practice, that's probably not really the case. Okay, as you can see, once we started to read the file of execution, continued in the application, printed end of file. Okay, so this is basically what I just said. Callback was only called once the file read was finished. How is it possible? So I am really getting off tangent here, but I think that's okay because this seems like a very important concept that they just kind of glossed over here, and I don't want to watch this video right now. I should probably be making notes on this, right? Okay. The event loop is the heart of Node.js. It is responsible for scheduling asynchronous operations. Before diving deeper, let's make sure we understand what event-driven programming is. Event-driven programming is a programming paradigm in which the flow of the program is determined by events such as user actions, most blah, blah, blah. Okay, in practice, it means that applications act on events. Also, as we have already learned in the first chapter, Node.js is single-threaded. From a developer's point of view, it means that you don't have to deal with the threads of synchronizing them. It abstracts away the complexity. So that's useful for things because, like, in a language like Java, you need, say you want to do a distributed thing where you want to fire off 10 different asynchronous requests. It's a huge pain, man. It's like you got to establish a thread pool executor, and then you got to define how many threads you want active, and then timeouts for those threads. And then you got to handle the scenarios where, like, there's partial failure and partial success. It becomes very, like, annoying. So if they can do this in a way that's easier on the eyes and easier to understand, I think that'll be something they really got going for them. So understand what the event loop more in detail. Continue watching this video. Oh, really? Okay, we're going to watch the video. Maybe bits of it, okay? I'm just going to skip around.
As in the event loop inside JavaScript.
And we're watching it on higher speed.
As he said, I work for Andyet, which is an awesome little dev shop / product company in the US. Look us up if you need help with real-time stuff. That's what we're working.
I don't care where
So
you
I kind
work.
of started a journey of, like, cool. I have a call stack, an event loop, a callback queue, and some other APIs and stuff. Right.
Okay, we're just going to find the spots.
Like, we're 18,
okay, here we go. This looks useful.
Like, and also, if you're an experienced JavaScript developer, hopefully give you some kind of fresh insights into how the runtime that you're using every day works so that you can kind of think about it a little better.
Sorry, I can't make it bigger.
If we look at the JavaScript runtime itself, like V8, for example, which is the runtime inside Chrome, this is a simplified view, really, of what the JavaScript runtime is. It's a heap, which is, we don't need to worry about that. It's kind of boring. It's just like where.
Okay, hold on. Let me see if I can make it bigger for you guys. There we go.
And it's not in, they don't exist, really, of what calls us help insights, for example, which is the runtime inside Chrome. This is a simplified view, really, of what the JavaScript runtime is. It's a heap, which is, we don't need to worry about that. It's kind of boring. It's just like where memory allocation happens.
Okay, so it's a heap runtime. Oh, man, what does that even say? I can't see. I can't see what it says. Okay.
And then there's the call stack, which is where your, like, stack frames are and all that kind of stuff. But if you, like, clone the V8 code base and grep for things like set timeout or DOM or XML HTTP request, they're not in there. They don't exist in V8, which is kind of a surprise to me, right? Like, set timeout's one of those, like, first things you use in JavaScript when you start thinking about async stuff. And it's
You guys remember set timeout? Because that was really cool at the time. That was like async, man. You can fire off a thread, do whatever you want. I remember that. And then you set it with an interval of 0, so it starts right away. That was the hack at the time to do asynchronous JavaScript.
It's not in the V8 source? Interesting. So over this 18 months of discovery, I've come to realize that this is really the bigger picture, and this is what I'm hoping to get you all kind of on board with today and understand what these pieces are.
So what is he saying here? Your stack. Okay, you're calling function. Oh, so it's a queue of events that get put on top, that get added to the queue as you pass through in the code, I guess. Okay.
So we have the V8 runtime, but then we have these things called web APIs, which are extra things that the browser needs people. Other people might get this, but we're going to quickly kind of move on from here. So full stack. Like this on your left, we've got a few functions. A function multiply, which multiplies two numbers.
Whoa.
Square, which calls multiply with that, the same number twice. A function which prints the square of a number by calling square and then calling console.log. And then at the bottom of our file, we actually run print square. Right? This code all good? Make sense? So if we run this, well, I should back up a step, sorry. So the call stack is basically, it's a data structure which records basically where in the program we are. So if we
Okay,
step
so
into
you're going to go, you're establishing all of these, and then you're calling this function. Okay, this is just going to be stacked on top of each other, right? Print square. Wait, what? Why did it skip down here? You're initializing these. Well, I guess it's just initialization. It's not actual calls to the method, so you're starting at the bottom.
Immediately inside print square, we're going to call square, which we're going to push onto the stack, which calls multiply. And now we hit a return statement, right? We multiply A and B, and we return. So I said when we return, we pop something off the stack. So pop.
Oh, I'm a dummy. Okay, sorry. These functions are calling each other. So you're calling print square, which is calling square here, and then which is calling multiply. Okay, I got it. So this is just your standard, standard stack here when you call functions that are embedded within each other.
Print square, console.log. Print square is now, there's no return, but it's implicit because we got to the end of the function, and we're done. Right? So that is like a visualization of the call stack. Does that make sense? Yes, well. Okay, great. So even if you haven't really thought about or visualized the call stack before, you've undoubtedly come across it when you've been doing certainly browser-side development. So if we have code like this, a function baz, which calls bar, which calls foo, which throws an error, then if we run this in Chrome, we see something like this in the DevTools, right? Uncall error, oops, and it prints the stack trace.
So that's interesting, right? So it's just like you have this gets put on the stack first, and then this
is the stack trace, right?
This is calling bar, that gets put on the stack. Then this calls foo, and that gets put on the stack. So the only thing that ever happens is oops, right? You never get the returns, like this never exits.
The state of the stack when that error happened. If you've heard the term like blowing the stack, then this is an example of that, right? Have a function foo which calls foo. So what's going to happen? Well, we run main, we call foo, which calls foo, which calls foo,
yeah,
which
is an infinite loop.
Calls foo. Yeah. So the big question then comes is like, what happens when things are slow? So we talk about blocking and blocking behavior, and blocking, there's no strict definition of what is and isn't blocking. Really, it's just code that is slow, right? So console.log is not very slow. Doing a while loop from 1 to 10 billion is kind of slow. Doing image processing is slow. Network requests are slow. So things which are slow and on that stack are what blocking means. So here's a little example. So let's say we have, this is like a fake bit of code, get synchronous, right? Like jQuery's like AJAX request. What would happen if those were synchronous requests? So forget what we know about async.
I think we all know how this works.
Slow, right?
You're calling in order, right? If you call synchronous, then you make this call, then it gets the thing, and then this one starts after foo finishes, and then blah, blah, blah. Whereas the alternative, the async way, would just like, it flies through this code. You fire off this request, this one, and they all return whenever they return. And if you want to do something when only all of them complete, you wait for the promises to resolve. At least that's what it was called. I'm sure the language is probably something similar. I'm just going to skip around here because I don't really want to watch all of this. Whoa. I got hit with an ad. What's happening? Internet? No. Go away.
Use the console.log for the future somehow. So then we skip straight onto JS-conf.vu, log that, and then 5 seconds later, we log there, right? Make sense? Happy? Basically, like that set timeout is doing something.
Okay, we know that.
And this is basically where the event loop comes in.
Okay, here we go.
Right, so I've been kind of partially lying to you and telling you that JavaScript can only do one thing at a time. That is true. JavaScript, the runtime, can only do one thing at a time. It can't make an AJAX request while you're doing other code. It can't do a set timeout while you're doing other code. The reason we can do things concurrently is that the browser is more than just the runtime. So remember this diagram. The JavaScript runtime can do one thing at a time, but the browser gives us these other things, right? It gives us these web APIs. These are effectively threads that you can't access like threads. You can just like make calls to. And those pieces of the browser are where this concurrency kicks in.
Is this the web workers thing?
If you're a backend person, this diagram looks basically identical for Node, except instead of web APIs, we have C++ APIs, right? And the threading and all that stuff is hidden from you by being run in like C++ land. Okay, so now that we have this picture, let's see how this code runs in this kind of more full picture of what a browser looks like. So, same as before. Run the code, console.log high.
Okay, your console logging high, and then it's going to set the timeout. It's going to put that on the stack. but it's asynchronous, so it's going to skip and go to the other thing.
Simple. Now we can see what happens when we call setTimeout. So when we call setTimeout, we pass this callback function and a delay to the setTimeout call. Now setTimeout is an API provided to us by the browser. Remember I said it doesn't live like in the V8 source. It's like extra stuff we get in the environment that we're running the JavaScript runtime in. So effectively we kick off a timer, right? The browser kicks off a timer for you. And now it's going to handle the countdown for you, right? So that means that our setTimeout call itself is now complete, so we can pop off the stack. JS.conf.eu, clear. So now we've got this timer in the web API, which 5 seconds later is going to complete. Now, the web API can't just like start modifying your code, right? It can't just like chuck stuff onto the stack when it's ready, because if it did, it would like just appear randomly in the middle of your code. So this is where the task queue or the callback queue kicks in. So basically, any of the web APIs, when they're done, they push your callback onto the task queue. And finally, we get to the event loop. The title of the talk is what the heck is the event loop. The event loop is like the simplest little piece in this whole equation, and it has one very simple job. The event loop's job is to look at the stack and look at the task queue. If the stack is empty, it takes the first thing on the queue and pushes it onto the stack, which effectively runs it, right? So here we can see that now the stack is clear. There's a callback in the task queue, so the event loop runs. It says, oh, I get to do something, here. Pushes the callback back onto the stack. Now remember, the stack is like JavaScript land, right? This is back inside V8. So the callback appears on the stack and gets run, console.log there, and we're done.
Okay, so I think I understand it. So you have this event loop that's constantly being monitored, and when things need to be done, they're added to the queue, and they get processed in best effort. Obviously they're going to be in order in which order they were added. I think that's about what I expect. Ooh, he's doing the thing, console log 0. This is what we used to do. I want to see what he has to say about this.
Probably one of the first encounters you would have had with async stuff, which is
yes. See, this was 5 years ago.
when for some weird reason someone says, oh, you have to call setTimeout 0. Like, okay,
that was me.
You want me to run the function in 0 time. Why would I wrap it in a setTimeout? Like the first time you come across this, if you're anything like me, you're like, okay, well, I sort of see this doing something, but I don't really know why. And the reason is, generally, if you're trying to defer something until the stack is clear, right? So we know looking at this, if you've written JavaScript, that we're just going to see the same result. We're going to see hi, we're going to see JS.conf.eu, and then there's going to somehow appear at the end. So running it, we can see how that happens. Console.log hi, setTimeout 0. Now that's going to complete immediately and push the callback onto the queue. But remember what I said about the event loop. It has to wait until the stack is clear before it can push the callback onto the stack. So your stack is going to continue to run, right? Your main file is going to continue to run, console.log JS.conf.eu, and clear. Now that we're clear, the event loop can kick in, run your callback. So that's
got it. So when your stack is clear, then you start taking items off the event loop and taking items off the task queue and processing them. I think that makes sense. I'm just going to kind of skirt around what he's doing because I don't think I need a more thorough example than what I just saw. Okay, so I think he's just giving more demos now. Okay, that served its purpose. So what did we just learn here? We learned that this concept of the event loop, there's a stack which holds kind of calls to be processed immediately. And then we have async calls get added to the event loop, right? And then the event loop is a queue. I should add that too. Event loop is a queue. Once the stack is cleared, calls from the event loop start getting executed in order of insertion. And that's FIFO, right? Q. Okay. Sorry, I just kind of want to see what I have left here because I'm probably going to end this shortly, but I want to see what else we got. Okay, so let's read the rest of this thing and then the rest of this thing, and then I'll call it because I just want to close out on these ideas. So async control flow, basic understanding how it works. Yes. To avoid the so-called, yes, callback hell, I know all about it. One thing you can do is start using async.js. Ooh, I can write that down. Async.js. Helps to structure your applications and makes control flow easier. Let's check a short example. Okay. So what is this doing? So you're going to do fs.stat on each of these different files. Research more. I need to look at this more because this seems useful. Results is now an array of stats for each file. Ooh. So I see. So the way that you had to do this before was something called like promise.of, and then you would give it all three promises for each function, and then you'd give a callback function to of, and it would do basically exactly what we're seeing here. The difference was that you need to declare the asynchronous functions or the asynchronous methods explicitly and then pass them in, but this is like a nice shorthand to do this quickly. So that's nice. So actually, let me write that. So shorthands for promise.all, I'll know what that means. Which is, I guess for people reading this, it may not make sense. So what should I say? Waiting for multiple promises to resolve before continuing, or sorry, before executing the callback function. I shouldn't say before continuing, because that's wrong, because you'll fly right through this and then, it's on completion or error. Now I wonder what happens in the error. Oh, okay. You get a argument for errors. Promises. Promise object is used for deferred and asynchronous computations. Promise object represents an operation that hasn't been completed yet, but is expected in the future. Okay, so I know all about promises. Promises are a big Java thing. So promises are like this library uses promises. This async library uses promises, but it just abstracts the complexity out of using them and managing them for you, and it gives you a couple nice shorthands. So you can just declare a function here, declare the different arguments that you want invoked in parallel, and then give you a callback function where you can, results is an array, as they say, and it's one-to-one, right? So the 0 index of the array will be the results of the file one fs.stack call. Second argument would be the results of this one. Third argument would be results of this one. So promises are the more lower level thing, at least it appears, that help build up these more complicated libraries. So it's used for deferred asynchronous. Okay, yeah. The previous example could be rewritten as follows. Okay, so here's how he shows you how async library makes it much simpler. So we're saying return a new promise with a resolve and a reject. So this is what you'd get. How does this work again? You take in two things, and then you're calling a function. Oh, okay. So when you're done, you call the resolve function with whatever you want to pass back, seems. And reject is when something breaks. So error case, use reject. Happy case, use resolve. Sounds good. Oh, here it is. Promises.all. Yeah, so you're waiting for each of these three things to resolve, and then you're logging the data. And I think you still get that array mapping between the input arguments and the result set. Okay, first Node.js server. All right, we're not doing that, at least right now. This was a good read, though. I'm going to put this in the chat if anyone wants to read this. I'll also put it in my notes. Good read for event loop stuff. So where did I leave off here? We got into, oh, sorry. Now where did I leave off here? Okay, so we just started talking about the event loop. Let's skim through the rest of this. Path module is quite helpful for working with file paths. This is basic relative paths. What does normalize do? Oh, okay, so strips the doubles. Okay, that's fine. Process module can be used for quite a few things, including accepting a command line. Oh, okay, so that's good. That's something I actually care about. Process module. Used to invoke CMD arguments. And what does it do here? Object to access environment variables using process.env. Oh, okay. Process. Wait, we can also use the process. Okay, that's cool. So environment variables accessed using process.env. Instead of importing this module, process is a reserved keyword. No way. That we can use. So let's make a file called RxJS and place this inside. Okay. So he's getting the arguments now. Now let's run node arg.js 1, 2. Oh, cool. So this is how you get command line arguments. So let's put that into process.argv gives you command line arguments. Yeah, I've seen that one before, Leon. So process.env.environment variable, where env_var is the name of the variable. Okay. Looks good. Okay, so HTTP. So no one really does this. We always use a library, right? Does anyone actually use this? I remember there was jQuery, and then there was something called Axios. I don't know if people still use that. But anyways, HTTP and HTTPS module allow you to create, server, and issue HTTP requests and responses. You can use this module on its own to create a server, but using it involves a fair amount of code and complexity. This module is one of the essential parts of Express, which is a framework which... Oh, okay, so HTTP module lets you basically establish a server. Huh. So listen on port 3000. Okay, so when you get a request on port 3000, you'll get this to the console log. Okay. That makes sense. Learn new node. What's this website? Oh, okay, so it's like a helper thing. Okay, I think this was, sorry, in the chat, that's the syntax, Express.js. Axios is popular for the fetching. Yeah, that seems about right. So this is more for like server side, just declaring your server, declaring what paths you're gonna listen on, the ports, and stuff like that. Express.js is one for the hosting. Yeah, it's the it's the basic REST API, right? The reason I like it is because it's so simple. It's like you just set up a couple lines and a couple imports and you're done. So let's go over what we learned today, because I think that's it for learning. I've been going for about an hour now. So let's talk about what we learned. So we saw a little bit about the exports. So every file is considered a module, and you can use your exports to export default functions and also objects on those exports. So if you have a file that's called helper, here you would get access to a say hello function on the helper import or helper module. So that's just what I'm showing here. And then there's the default export, which gives you access to just the default function here by invoking the module name. Destructuring allows you shorthand for getting the keys within an object, so you can refer to them without having to do like object.name. It just lets you get it by using the shorthand. And there's also an array concept that does something similar, but I need to read up about that. We looked at the event loop, which is basically the idea that NodeJS is asynchronous, and blocking calls are placed on the stack and take priority over asynchronous calls. So when the event loop is, when the stack is cleared with blocking calls, then the kind of functions that require processing are taken off the queue in FIFO order and processed. So it's possible that you can submit an asynchronous call, and if something else is pending, you can have a very long period of time before you actually get a response. So it's dependent on what else is going on in the application. Async Js, it's a shorthand thing for managing a bunch of promises that let you do waiting. They'll let you resolve all at once and access the results all at once of multiple promises. So good for firing off a bunch of requests asynchronously and then returning back. So it's like you fire off two things, and then when they both return, then you perform some function. And the input to that function will be the results of the two things. Then we have the process module, allows you to invoke command line arguments. argv gives you the arguments to the script. Or to the function, to the script, that's the right language. Environment variables access using process.env, and Leon pointed out here that to get environment variables, you just use this syntax here. And then I have this good read here. So I think I'm done for tonight, guys. If you have any questions, let me know. But this has been useful, so I'm going to continue this. There's a whole bunch of other lessons that I want to do here on this. I don't know how many there are, like maybe 10 or so, whatever. But I'm eventually going to do another one where I actually, install everything and play with it a little bit and screw around with asynchronous functions and ordering and stuff like that. So that's what's going to be in stock for my next Let's Learn series. It'll be a continuation of this. And yeah, so thanks everyone for tuning in. I really appreciate it. And thanks for all the questions. Leon, Sadar, thanks for joining. And I will catch you guys next time. And I have another video coming out on Friday, so keep an eye out for that. But yeah, everyone, hope you have a good night, or if it's in the afternoon, have a good afternoon. I will catch you next time. Thank you.